Good afternoon, guys. Welcome to 43rd lecture of fluid mechanics. We are in the unit 3 discussing a new topic today, that is flow of fluid through pipes in series connection. So in the previous class, we have discussed about the topic called uh, hydraulic gradient line and total energy line, their concepts and the problems. Today's class will discuss about a new topic, that is flow through pipes in series connection. So what happens when the fluid, that is a water or a oil, is flowing in the pipe, which where they are connected in series connection. These things we'll discuss in this class. So we have completed the minor losses, we have completed the total energy line, we have completed the hydraulic gradient line, and we are discussing the pipes in series. Okay, next. So in the last class theories and problems, we have solved some derivations and also the problems. So keep these formulas in mind, or I will send you a PPT. Keep these formulas in mind for till the end of this unit. Why? Because everywhere you have to, anywhere you can apply this formula. So the energy loss due to the friction. So the energy loss due to the friction is given by the Darcy-Weisbach formula, that is HF is equals to 4 into F into L into V square. Right? F is equal to coefficient of friction, L is equal to length of the pipe, V is equal to velocity, V is equal to diameter of the pipe, 2 into gravity. So that is a formula for major loss due to friction. So major losses pipes lo ela jarugutundi because of friction. Two cases, Darcy-Weisbach equation and also the Sezes formula. Minor losses ela jarugutundi based upon 7 conditions. Okay. Now the next formula in this major loss is V is equals to capital C into root into mi, capital C into root into mi. Okay. Now where C is constant. Okay. Where m is equals to hydraulic mean depth, that is d by 4 for pipe running full. Next, V is equals to velocity of the pipe. V is velocity of the pipe, and I is loss of head per unit length. So loss of head per unit length. Total length మీద unit length loss is equals to HF by total length of the pipe. Therefore, HF is equals to length into I, that is I is obtained by Sezes formula. I is obtained by the Sezes formula. So these are the two formulas for the major losses in the pipes. Okay. Next, coming to the minor losses in the pipes. So loss of it due to the expansion or enlargement. Expansion or enlargement. అంటే ఇక్కడ ఏంటి, the pipe ఒక diameter ఉంటుంది, pipe diameter ఉన్నట్టుండి the pipe diameter will increase. So these problems also we have discussed. Their formula is HC is equals to V1 minus V2 whole square divided by 2G. Okay na? Where V1 is equal to velocity in small pipe, V2 is equals to velocity in larger pipe. Next, loss of it due to the contraction. Contraction అంటే ఏంటి? సో పైప్ ఇలా ఉంటుంది, ఉన్నట్టుండి పైప్ డయామీటర్ అనేది రెడ్యూస్ అయిపోయి కిందకు వస్తుంది. సో ద పైప్ is reduced. So for this, the formula HC is equals to 1 by CC minus 1 V square by 2G. V2 square by 2G. That is a formula for sudden contraction. Next, CC the CC value, this one for coefficient of contraction, that is equals to, when CC is not given this one, when CC value ఇచ్చినప్పుడు ఈ ఫార్ములా యూస్ చేయాలి. Then loss of head at the entrance of the pipe. Pipe entrance దగ్గర అంటే ఈ pipe entrance దగ్గర ఎంత ఉంటుంది, HI is equals to 0.5 into V square by 2G. That is equal to loss of head at entrance of the pipe. Next, loss of head at exit of the pipe ఎంత, V square by 2G. That is a formula for loss of head at the exit of the pipe, H naught. So these are the formulas for minor losses. Next one, hydraulic gradient line and total energy line. So this definition, I think definitely you'll get in the part A. So what is hydraulic gradient line? It is defined as the line which gives the sum of pressure head plus datum head of the flowing pipe, fluid flowing in the pipe with respect to some reference line. Okay. So briefly you are selling them as HGL. Then what is total energy line? It is defined as a line which gives the sum of pressure head plus datum head plus kinetic head with some reference line. It is also called as TEL. Ante total energy line gives three things, that is pressure head, datum head and kinetic head. And what is HGL? Total energy line nunchi which we will remove kinetic head there, then automatically it is a hydraulic gradient line. Okay, so for this also we have done some problems. So this is the definition of HGL. HGL, this is the definition of the TEL. Okay, next. Okay, this is a pipe diameter is called, so this is not there. So next thing, next concept to discuss is flow through pipes. Flow through pipes in series or flow through compound pipes. 350, 3, 10, 20, 310, 310. So the next concept to be discussed is a flow of fluid through pipes in series connection or flow of fluid in pipes through compound pipes. Okay, now the pipes in series or compound or defined as the pipes at different lengths and different diameters connected end to end in series to form a pipe connection. So the flow of through pipes in series ante enti? So the pipes are connected in series connection, one end to other end, but the diameters of the pipes are different. It depends upon the application. That is nothing but flow through the pipes in series connection. So ఇక్కడ ఎలా చెప్తున్నాం? So if you draw a pipe of so and so diameter, ఇక్కడ నుంచి పైప్ ఇంకొక పైప్ కనెక్షన్. ద పైప్ కనెక్షన్ ఇస్ బిగ్గర్ పైప్. మళ్ళీ ఇక్కడ నుంచి అగైన్ స్మాలర్ పైప్ అనుకుందాం, రైట్? స్మాలర్ పైప్, అగైన్ ఇక్కడ నుంచి ఇంకొక బిగ్ పైప్, రైట్? అగైన్ ఇక్కడ నుంచి ఇంకొక స్మాల్ పైప్. సో ద చేంజింగ్ ఇన్ ద డయామీటర్ ఆఫ్ ద పైప్, వేర్ వీఆర్ హ్యావింగ్ వన్ పైప్, వేర్ వీఆర్ హ్యావింగ్ సెకండ్ పైప్, వేర్ యూ ఆర్ హ్యావింగ్ థర్డ్ పైప్, వేర్ యూ ఆర్ హ్యావింగ్ ఫోర్త్ పైప్. This one is fifth pipe. So 5 pipes ekkada unnai connection, 1 2 3 4 5 series connection lo undi. Now these are connected in series, but the diameters of the pipes of different diameters. This is nothing but flow through pipes in series connection. So deen meeda manamu will derive some derivation in these pipes and we'll get some formula. Based on this formula we'll do some problems. Okay, now see the derivation. So you can draw, see here, F1 is a pipe 1, F2 is a pipe 2, F3 is a pipe 3. So ఇది pipe connection series లో ఉంది. It can be slant or it can be horizontal. Top head నుంచి bottom head ఉండొచ్చు, లేదంటే same head మీద ఉండొచ్చు. Now taking this type of configuration, now see, let L1 L2, this is a length L1, this is a length L2, this is a length L3. Length L1 L2 L3 are the length of the pipes F1 F2 and F3 respectively. So L1 L2 L3 వచ్చేసి length of the pipe 1 2 3 pipes. You are having first pipe, you are having second pipe, you are having third pipe. So ప్రతిదానికి లెంత్లు ఇచ్చాడు. Let L1 L2 L3. Next D1 D2 D3 are diameters of pipes 1 2 3 respectively. So D1 is the diameter of the length L1, D2 is the diameter of the length L2, D3 is the diameter of length L3 respectively. Next, V1 is a velocity of flow through pipes 1 2 3. So V1 is a velocity of pipes through L1, L2 and L3. Next, F1 F2 F3, these are the coefficients of the pipes 1 2 and 3. This is a given data. Then H is equal to height. H is equals to difference of water level between the two tanks. So H and H ikkada ichchadu. So here the water level వచ్చేసి ఈ tank మీద ఇక్కడికి ఉంది, ఇక్కడ water level వచ్చేసి ఇక్కడ ఉంది. Therefore the difference in the water level is H. So ఇలా you have one configuration. Now what is the thing you have to do? The discharge passing through each pipe is same. Okay, the discharge, whatever the discharge is passing through the pipe for each pipe is same. Therefore Q is equals to A1 V1, that is equal to A2 V2, that is equal to A3 V3. Now the difference in the liquid surface levels, the difference in the liquid surface levels is equal to the sum of the total head loss in the pipe. The difference in the surface, the difference in the liquid surface level is equal to the sum of the total head loss in the pipes. That is equals to H is equals to, then what is here? The total head loss in the pipe. Therefore, 0.5 V1 square by 2G, entrance formula. Next, head loss 4F1 L1 V1 square by D1 into 2G plus tarvata ikkada, that is 0.5 V2 square by 2G. Tarvata head loss here 4F2 L2 V2 by 2G into D2 into 2G. Malli ప్లస్ ఇక్కడ ఏమైంది మళ్ళీ ఇక్కడ హియర్. సో ఈ ఫార్ములా ఏంటిది? దిస్ ఇస్ ఎక్స్పాన్షన్. ఓకేనా, ఇక్కడ ఎక్స్పాన్షన్ ఏం లేదు, ఇక్కడ డైరెక్ట్లీ మనకి ఎంట్రన్స్ కాబట్టి ఎంట్రన్స్ ఫార్ములా వేయండి. దిస్ ఇస్ ఎంట్రన్స్ ఫార్ములా. ఓకే, దిస్ ఇస్ ద ఎంట్రన్స్ ఫార్ములా. దిస్ వన్ ఇస్ అ head loss formula. Again this one is contracting, this one contracting. Again this one formula, again this H2, this one is H2 plus మళ్ళీ ఇక్కడ ఏం జరిగింది? sudden enlargement. So sudden enlargement is V2 minus V3 by 2G whole square. మళ్ళీ ఇక్కడ ఏం జరిగింది? head loss 4F3 L3 V3 square by D3 into 2G. తర్వాత ఇక్కడ ఏం జరిగింది? ఎగ్జిట్ ఏంటి ఫార్ములా? V square by 2G, అంటే థర్డ్ వెలాసిటీ కాబట్టి V3 square by 2G. సో ఈ మూడిటికి ఈక్వేషన్, ఈ మొత్తం ఈక్వేషన్ రాయండి. నెక్స్ట్ వాట్ హ్యాపెన్స్ ఆఫ్టర్ సమ్ సింప్లిఫైయింగ్, ఇఫ్ మైనర్ లాసెస్ ని మనం నెగ్లెక్ట్ చేసాం అనుకోండి, then the above the equation is becoming as, so minor losses we are neglecting this losses 1, this 2, this 3 loss. ఈ మూడిటిని నెగ్లెక్ట్ చేస్తే మైనర్ లాసెస్ ని we are getting 4F1 L1 V1 square by D1 into 2G plus 4F2 L2 V2 square by D2 into 2G plus 4F3 L3 V3 square by D3 into 2G. సో మనకి ఏం పోయినాయి ఇక్కడ? సో ఇది క్యాన్సిల్ అయింది, ఇది క్యాన్సిల్ అయింది, ఇది క్యాన్సిల్ అయింది. ఓన్లీ మనకి హెడ్ లాస్ మాత్రమే ఉంది. Therefore, so if the coefficient of friction is same, so coefficient of friction is same for all pipes, therefore F1 is equal to F3 is equal to F1, F2, F3 is equal to F, then the equation ఎలా వస్తుంది మనకి? H is equals to 4 into F L1 V1 square plus 4 into F L2 V square plus 4 into F L3 V square divided by this so on. నెక్స్ట్ దీనిలో కామన్ గా ఏం తీసుకున్నాము? 4F by 2G బయటకు తీసుకొని L1 V1 square by D1 plus L2 V2 square by D2 plus L3 V3 square by D3. This is the formula for pipes in series connection. Okay, this is a formula. Now based upon this formula you have to do some problems. So if you get a question, derive the equation for flow of pipes in series అన్నప్పుడు simple గా you have to draw this figure and you have to derive this figure and you have to get the formula. I think this is very very simple derivation so that you can do it. అర్థమైందా? Got it? Yes. See, simply draw the figure. Okay, name the figures and simply just Q discharge అనేది ఈక్వల్ గా వెళ్తుంది కాబట్టి A1 V1 A2 V3 A3 V3. Therefore the difference in the liquid surface levels is equal to the sum of total losses in the pipe. The sum of total head loss in the pipe. The difference in the surface levels is equals to sum of total head loss in the pipes and రాసేసి H is equals to ఇక్కడ ఒక ఫార్ములా వస్తుంది, ఈ పైప్ లో ఒక ఫార్ములా వస్తుంది, ఇక్కడ ఒక ఫార్ములా వస్తుంది. 3 ఇక్కడికి అయిపోతుంది, 4th ఫార్ములా, 5th ఫార్ములా, 6th ఫార్ములా, 7th ఫార్ములా, అంతే కదా? 1 2 3 4 5 6 and 7. దీని లోపల మనము మైనర్ లాసెస్ తీసేస్తే ఫార్ములా మనకి ఇలా వస్తుంది. తర్వాత ఫ్రిక్షన్ ఈక్వల్ గా అనుకున్నప్పుడు F1 F2 F3 ప్లేస్ లో F పెట్టేస్తే ఇలా వస్తుంది. కామన్లీ వీఆర్ టేకింగ్ 4F by 2G, then the formula is this one. So based upon the formula, now we are doing the problems. So if you see the first problem, I think, yeah, yes. If you see the first problem, the difference in the water surface levels in two tanks which are connected by three pipes in series of lengths or 300 meters, 170 meters, 210 meters. So మనకి ఎన్ని పైపులు ఇచ్చాడు? 3 pipes ఇచ్చాడు which are connected in series అని చెప్తున్నాడు. What is the pipe length? First pipe length is 300, second pipe length is 170, third pipe length is 210. Then what are the diameters? The diameters of the first pipe is 300, second pipe is 200, third pipe is 400, is 12 meter. Okay. Determine the rate of flow అంటే Q కనుక్కోవాలి. Determine the rate of flow of water if coefficient of friction or F1 is equal to 0.005, Ft is equal to 0.0052, F3 is equal to 0.0048, considering the minor losses also, neglecting the major, considering minor losses also. Second class లో ఏంటి, neglecting the minor losses అంటే మైనర్ లాసెస్ని పెట్టుకొని ఫార్ములా వేసి చేయండి, మైనర్ లాసెస్ లేకుండా ఫార్ములా చేయండి. I think this will be easily understanding by solving the problem. So same above problem, just మనకి two cases లో ఇచ్చాడు, right? So we're having one problem to discuss. సేమ్ ఇదే ఫిగర్ వేయండి ఎగ్జామ్కి. ఇక్కడ L1 ప్లేస్లో వాల్యూస్ రాయండి సపరేట్గా, then start doing the problem. Then what is the difference of water level? The difference of water level is 12 meters అన్నాడు. Therefore H is equals to H value is 12. Okay, next, what is the length of the pipe L1? L1 is equals to 300 meters. So what is the diameter of that one? 300 mm, that is 0.3 meters. Next, pipe length 2, L2 is equals to 170 meters, that is diameter D2 is equals to 0.2 meters. Next, length of pipe 3, L3 is equals to 210 meters, then diameter D3 is equals to 0.4 meters. Next, F1, coefficient of friction F1 is equals to 0.005. Next, coefficient of friction F2 is equals to 0.0052. Next, coefficient of friction F3 is equals to 0.0048. So ఇప్పుడు ఏం కనుక్కోవాలి? Consider minor losses also. Now considering minor losses, let V1, V2, V3 are the velocities in the first pipe, second pipe and third pipe. From the continuity equation, we have A1 V1 is equals to A2 V2 is equals to A3 V3. So మనం డెరివేషన్ లో చేసుకున్నట్టే this continuity equation, right? Same ఇదే తీసుకుందాం. Next, therefore V2 is equals to A1 V1 by A2. So A1 pi by 4 d square into V1 divided by pi by 4 d square into D2. So pi by 4 this is the D1 square by D2 square into V1, that is equals to value వేస్తే we are getting V2 is equals to 2.25 V1. Next, V3 కూడా సేమ్ అదే ప్రాసెస్ లో చేస్తే therefore V3 is equals to 0.5625 V1. Okay, next, using the equation 11.12, what is 11.12? This one, ఈ పెద్ద ఈక్వేషన్ తీసుకోండి. ఈ ఈక్వేషన్ లో యూఆర్ హ్యావింగ్ మైనర్ లాసెస్ ప్లస్ మేజర్ లాసెస్. ఓకే, సో ఇక్కడ ఏం చెప్పాడు, మైనర్ లాసెస్ కూడా యూజ్ చేసేయమన్నాడు. నౌ టేకింగ్ వన్, సో దిస్ వన్ ఎంట్రన్స్ దగ్గర, పైప్ లోపల, పైప్ ఎగ్జిట్ దగ్గర, మళ్ళీ పైప్ లోపల, రైట్, మళ్ళీ పైప్ ఎగ్జిట్ దగ్గర, మళ్ళీ పైప్ లోపల, సిక్స్త్ వన్, తర్వాత పైప్ ఎగ్జిట్ లోపల. సో లైక్ దిస్ 7 ఫార్ములాస్ మనము టోటల్గా రాయాలి. Now substituting, so we need the velocities కాబట్టి, now substituting V2 and V3. So V2 value వచ్చేసి this one, V3 value వచ్చేసి this one. Now substituting the values in this above one, so H is equal to 12 ఇచ్చాడు, that implies 0.5 V1 square by 2G, 4 F1 value తెలుసు, L1 value తెలుసు, V1 square by D1 value తెలుసు 2 into G plus 0.5 V2 ప్లేస్లో ఏం రాయాలి, 2.25 రాయాలి. సో దిస్ వన్ 2.25 V1 square by 2G plus 4 F2 value రాయండి, L2 value రాయండి, V2 ప్లేస్లో at this value. So like this apply all the values. సో అప్లయింగ్ ఆల్ ది వాల్యూస్, సో మీకు టోటల్గా ఇంత పెద్ద ఈక్వేషన్ వస్తుంది. అపాన్ సాల్వింగ్ దిస్ వన్, అపాన్ సాల్వింగ్ దిస్ వన్ 12 ఈజ్ ఈక్వల్ టు v1 స్క్వేర్ బై 2g కామన్గా తీసుకొని 0.5, 20, 2.5, 89.5, 2.8, 3.1, 0.3 ఇవన్నీ యాడ్ చేస్తే మీకు ఇది వస్తుంది. therefore v1 is equals to root of 12 into this 2g కదా, 12 into ఈ 12 ఇటు వస్తుంది కాబట్టి 2 into 9.81 divided by 118, that is equal to 1.407. v1 వాల్యూ వచ్చేసింది. now we know the velocity or rate of flow q is equals to area into velocity, that is equal to a1 into v1. therefore pi by 4 v1 square into v1 is equal v1 value pi by 4 0.3 square into v1 value చేస్తే you are getting area. After getting the area 99.45 liters per second, this is a formula what we, this is the answer what we require. ఏం కనుక్కున్నాడు ఇక్కడ, determine the rate of flow of water అన్నాడు. now సెకండ్ కేసులో ఏమి ఇచ్చాడు, నెగ్లెక్టింగ్ ద మైనర్ లాసెస్. సో ఈ మైనర్ లాసెస్ నెగ్లెక్ట్ చేస్తే 1 పోతుంది, 3 పోతుంది, 5 పోతుంది, 7 పోతుంది. పోయిన తర్వాత పాత ఆ 246 ఫార్ములాస్ తీసుకుంటే, అంటే పైప్ లోపల ఫ్రిక్షన్ కదా, లోపల ఉన్న ఫార్ములాస్ తీసుకుంటే నో అప్లయింగ్ హెచ్ ఇది కూడా సో therefore 12 is equal to v1 square by 2g కామన్ తీసుకొని applying the values like this. so finally after keep on simplifying this one, we are getting v1 is equals to 1.44. ఇక్కడ v1 ఎంత వచ్చింది, 1.4 వచ్చింది. ఇక్కడ కూడా approximately 1.4 వచ్చింది. now the discharge q is equals to v1 at a1. after simplifying we are getting the discharge is 102. ఇక్కడ మనకు డిశ్చార్జ్ ఎంత వచ్చింది, 99 వచ్చింది. so there is a difference between the minor losses and major losses. so like this you have to solve the problem by whenever the pipes are in series connection. hope you understood, right? so I think this is a very simple problem where the pipes are in series connection. so దీనిలో మీరు కనుక్కోవాల్సింది ఎంట్రన్స్ ఇన్ ద పైప్, తర్వాత ఎగ్జిట్, తర్వాత ఇన్ ద పైప్, తర్వాత ఎంట్రన్స్ ఇన్ ద పైప్, తర్వాత ఎగ్జిట్, like this. so like this you will get 3 pipes ఉంటే 7 ఫార్ములాస్ వస్తుంది, 4 pipes ఉంటే ఇంకొంచెం 2 యాడ్ అవుతుంది. got it? so that is not logic. జస్ట్ మనకి పైప్ ఎంట్రన్స్ ఎక్కడ స్టార్ట్ అయింది, పైప్ లోపల ఫ్రిక్షన్ మేజర్ జరుగుతుంది, మళ్ళీ ఎగ్జిట్ దగ్గర కొంచెం జరుగుతుంది, మళ్ళీ లోపల ఎక్కువ జరుగుతుంది బికాస్ ఆఫ్ ఫ్రిక్షన్. సో లైక్ దిస్ యూ హ్యావ్ టు అనలైజ్ బై డ్రాయింగ్ ద ఫిగర్. ఓకేనా? నెక్స్ట్ క్వశ్చన్. the 3 pipes 400 mm, 200 mm, 300 mm having the length 400 meters, 200 meters, 300 meters. Same. The pipes having the diameter same, length are same. They are connected in series to make a compound pipe. The ends of this compound pipe are connected with 2 tanks. The ends of this compound pipe ఏం జరిగింది, the ends of this compound pipe are connected with 2 tanks whose difference of water levels are 16 meters. Therefore h is equals to 16 meters if the coefficient of friction for all these pipes are same and equal to 0.05. so ఇక్కడ ముందు ప్రాబ్లంలో f is equal to different, here the f is same 0.005. determine the discharge, you కనుక్కోవాలి. determine the discharge through the compound pipe neglecting the minor loss and then include them. అంటే ఫస్ట్ ఏం చెప్పాడు, ఫస్ట్ కేసులో నెగ్లెక్ట్ ద మైనర్ లాస్ అన్నాడు, సెకండ్ కేసులో ఇంక్లూడ్ ద మైనర్ లాస్ అన్నాడు. సో సేమ్ ప్రాబ్లం ముందులాగానే, బట్ హియర్ ఏం జరిగింది, ద కోఎఫిషియంట్ ఆఫ్ ఫ్రిక్షన్ ఈజ్ సేమ్ వాల్యూ. సో జస్ట్ ఫర్ యువర్ అండర్స్టాండింగ్ విల్ సాల్వ్ దిస్ ప్రాబ్లం. ఓకేనా? సో యూ హ్యావ్ గివెన్ ద all the things here. The f is equals to 0.005. okay, therefore what is the difference in the water levels, h is equals to 16. next, pipe 1 diameter, pipe 1 length anta 400 mm, d1 anta 0.4, pipe 2 diameter anta 200 mm, d2 anta 0.2 meter, pipe 3 diameter anta length anta 300 mm, 300 meters, d2 and d3 anta 0.3 meters. therefore what is the coefficient of friction, f is equals to 1 is equals to f2 is equal to f3. now ఏం కనుక్కోమన్నాడు, find the determine the discharge. so by taking the continuity equation, V1, V2 are the velocities at the first, second, and third pipes. ఇది ఆటోమేటిక్గా రాసేయండి. Then what is the continuity equation? A1 V1 is equal to A2 V2 is equals to A3 V3. Therefore, V2 is equals to same. Apply చేయండి. So we are getting V2 is equals to 4V1. Okay. Next, V3 is equals to 1.77 V1. Now taking the big formula, that is series formula, without అన్నాడు. Without కాబట్టి take only major loss. Pipe 1, pipe 2, pipe 3 లో take only major loss. Now add these values. H place లో 16 పెట్టండి. 4 into F1 same value 400 into V1 square by 0.4 into 2 into 9.81. 4 into 0.005 into 200 into 4 V1 square by D2 formula, D2 value 2 into 9.81. This one values వెక్కిచ్చేసి into 1.77 V1 square. V3 is equals to this one. Now after substituting these values, taking this V1 square by 2G common, ఇవన్నీ values substitute చేస్తే finally you are getting V1 is equals to root of 16 into 2 into 9.81, 403.14, that is equal to 0.008. That is a V1 value. Next, so V1 value వచ్చింది కాబట్టి discharge లో take any discharge A1 V1, therefore pi by 4 d square into 0.882, that is equal to this one. So that is a value. Now what is the second option? Discharge through the compound pipe. Discharge through compound pipe considering the minor losses also. Therefore, so ikkada em chesaru, ikkada individual ga rasadu, there is no problem. If total ga rasina kuda you will get an answer. So inlet దగ్గర ఏంటి ఫార్ములా 0.5 V1 square by 2G. Second ఏంటి, between first and second pipe due to contraction. So HC is equal to 0.5 V2 square by 2G. That is equal to 0.5 4V1 square by 2G, where V2 is equal to 4V1. Therefore, after solving this one, we are getting 8 into V1 square by 2G. Next, between second pipe and a third pipe due to sudden enlargement, E formula. So solving this one, applying this one, we are getting this one. At the outlet of the third pipe, that is H naught is equal to V3 square by 2G, that is equal to, applying the value, substituting, keep on substituting, you are getting this one. Now the major losses are, so వీటన్నిటికీ solve చేస్తే we have already got the major losses. The major losses is 4.16. So okay, so ఈ major losses apply here. Same 4V1 into 11 into V1 square, ఇవన్నీ చేసి applying the same values. Okay, so sum of the minor losses and major losses. దీనిలో వచ్చిన సమ్ము, దీనిలో వచ్చిన సమ్, total keep on adding, we are getting this value. Okay, now but the total loss must be equal to 16 meters. Therefore 419.746 into V1 square by 2G is equals to 16. Therefore V1 is equals to 0.864. Therefore what is Q here? Q is equals to A1 V1, that is equals to 0.1085. So ముందు ఎంత వచ్చింది మనకి 0.1108. So similarly approximate value we have got. ఇక్కడ value V1 ఎంత వచ్చింది 0.0882, ఇక్కడ ఎంత వచ్చింది 0.846. So we are not comparing, just we are seeing minor losses లేకుండా చేస్తే ఎంత వచ్చింది, minor losses పెట్టుకొని చేస్తే how much value we have got. Approximately we have got the similar values, so that our answer is correct. That's why మీకు 2 problems practice కోసం ఇచ్చాం. So initial case లో values are similar before minor losses and adding the minor losses. Here also the values are approximately similar. Got it? So like this, you have to solve the problems whenever you are getting the question under pipes in series connection. Hope you understand the problems. Yes. అర్థమైంది కదా? How to solve the problem? Very simple, by taking this formula. ఈ formula. Okay. Next, equivalent pipes. Next concept is equivalent pipe. So in this equivalent pipes also you are having one problem, so that we can complete easily, no issues. Next, This is defined as the pipe of uniform diameter having loss of head and discharge equal to the loss of head and discharge of compound pipe consisting of several pipes of different lengths and diameters. The uniform diameter of the equivalent pipe is called equivalent size of the pipe. The length of the equivalent pipe is the equal to the sum of the lengths of the compound pipe consisting of different pipes. So equivalent pipes ante enti? The pipes having the same diameter but different lengths and also the different material. Okay, that are nothing but equivalent pipe concept. Okay, now taking the analysis, let L1 is equal to length of the pipe and D1 is equal to diameter of the pipe. Let L2 is equal to length of the pipe, D2 is equal to diameter of the pipe. L3 is equal to length of the pipe 3 and D3 is equal to diameter of the pipe 3. Then H is equal to head loss. L is equal to total length of the equivalent pipe. D is equal to diameter of the equivalent pipe. Therefore, equal length of the equivalent pipe is equal to L1 plus L2 plus L3. Therefore, the total loss in the compound pipe neglecting the minor losses. So, minor loss తీసేసి ఈ formulas రాయండి. That is H is equals to L1 plus L2 plus L3. That is 4F1 into L1 into V1 square by D1 into 2G plus 4F2 L2 V2 square by D2 into 2G 4F3 L3 V3 square by D3 into 2G. Assuming that the coefficient of friction F1 is equal to F2 is equal to F3 is equal to F. Now, the discharge according to continuity equation A1 V1 is equal to A2 V3 is equal to A3 V3. That implies pi by 4 D1 square by into V1 is equals to pi by 4 dt square by V2 is equals to pi by 4 D3 square by V3. Now, removing pi by 4, pi by 4, pi by 4, V1 is equals to, or we can write as it is. So V1 is equals to 4q by pi D1 square. V2 is equals to 4q by pi dt square pi D3 square. Now substituting these values in 4.4, this దీనిలో substitute చేస్తే, therefore H is equals to 4F1 into V1 square కి ఇది, V2 square కి ఇది, V3 square కి ఇది, this one, ఈ formula apply చేస్తాడు, right? This formulas, okay? By D1 by into 2G, D2 into 2G, D3 into 2G. Therefore, common గా తీసుకొని 4 into, that is 4 into 16, 4 square into 16 కదా, 16 FQ square by pi square by 2G into L1 by D1 5, L2 by D2 5 plus L3 by D3 5. So that is kept as other one. Now head loss in the equivalent pipe H is equals to normal formula, taking the same values of F as a compound size, where F is equals to Q by A, that is equal to 4 into Q by D square. So substituting V value, ఇది ఇక్కడ substitute చేసాం అనుకో D place లోపల. Therefore 4 into F into L into V by T into 2G, that is equal to this one. This is 16 అనుకుంటే. Now head loss in the compound pipe and in equivalent pipe is same, hence the equations 11.15 and 11.16. So ఈ రెండు బేస్ చేసుకొని, ఈ రెండు బేస్ చేసుకుంటే 4 into 16 F Q square by pi square by 2G into this one is equal to this one చేసుకుంటే, so therefore cancelling this one and this one, we are getting L1 by D1 5, L2 by D2 5, L3 by D3 5 is equals to L by D5, or reverse చేసుకొని L by D5 is equals to so on పెట్టుకున్నప్పుడు, this value is known as Dupix's equation. This value is known as Dupix's equation. In this, the equation L is equals to L1 plus L2 plus L3 and D1 plus D2 plus D3 is equals to are known as the equivalent size of the pipe, that is the value of the D can be determined. So finally in the equivalent pipes, so we have to find the value of the D. So like this, the DuPont's equation, by taking the equivalent pipes concept, it has been derived. Hope you understood. This is also very simple derivation, just like your pipes in series. Take the given data, every equivalent pipe kabatti L is equal to 1 plus 2 plus 3. So having the formulas, assuming all F is equal to F, So continuity equation, substituting in the equation, we are getting the head loss. Separating equivalent pipe తీసుకోండి, that is for separately or maintaining. So equalizing both the things. So crossing this two. So we got LD5 is equals to L1 by D1 square, D1 5 plus L2 by D2 5 plus L3 by DT 5. So that is a formula what we have obtained. This formula is known as Dupic's formula. Okay. Next problem. Under this question, under this concept, the three pipes of length 800 meters, 500 meters, 400 meters. Diameters and the 500, 400, 300 are connected in series. These pipes are to be replaced with a single pipe of length 1700. Find the diameter of the single pipe. So, three pipes ఇచ్చాడు, three diameters ఇచ్చాడు, connected in series అని చెప్పాడు. These pipes are to be replaced. ఆ ప్లేస్లో పెద్ద పైప్ లెంత్ 1700 పైప్ తీసుకొని రీప్లేస్ చేయమని చెప్పాడు. దెన్ వాట్ విల్ బి ద డయామీటర్ ఆఫ్ ద సింగిల్ పైప్? దట్ ఇస్ అ ప్రాబ్లం. ఈ ఇంట్లో ప్రాబ్లం వచ్చినప్పుడు దెన్ యూ హావ్ టు గో విత్ ద ఈక్వివలెంట్ పైప్స్. దెన్ యూ హావ్ టు గో విత్ ద ఈక్వివలెంట్ పైప్. Then what is the given data? The given data, the length of the pipe 1 is equals to L1 is equal to 800 and D1 is equals to 500. Length of the pipe 2, L2 is equals to 500 and D2 is equals to 400. L3 is equals to pipe L3 is equals to 400. Diameter is equals to 300. Therefore, L1 value, L2 value, L3 value, D1 value, D2 value, D3 value, we have got it. Then what is the other thing he has given? The total length of single pipe is 1700 meters. And what is the thing to find? Let the diameter of the pipe, let the diameter of equivalent single pipe is D. Let the diameter of equivalent single pipe is D. Next, applying the equation 11.17 on that. What is the 11.17? So this one. Applying the equation 11.17 here. Yeah, that is L by D5 is equals to, this is a formula. This is a formula anukunte. So what is the total length? 1700 by D square, D to the power of 5 divided by 18 by D1 square 0.5, 0.4 to the power of 5, 0.3 to the power of 5. So ఈ పైన ఉన్న దాన్ని ఈక్వేట్ చేస్తే we are getting to 25,600, 48,828, 1,64,000, so on. So that total గా మీరు చేస్తే that is getting 23 lakhs, 2,39,037. Therefore, D5 is equals to 1700 divided by so on. So that is this one. Therefore, D is equals to, ఇది మనము చేస్తే simplify చేస్తే finally we are getting 0.3718. That is equal to 371.8 mm of diameter for the given length of 1700. That is the concept of this compound pipes. So hope you understood the concept, right? So we'll stop the class till here. So we'll discuss the class in the next session. So that is flow through parallel pipes. Flow through parallel pipes. 13.5, 36, 39. Okay, 340. Okay, so in this session, what we have learned, we have learned about the formulas, derivation of the pipes in series, and the derivation of equivalent pipes and the formula. Okay, na? So therefore, the pipes in series law. So we have took the two tanks, three pipes. We have drawn the major and minor losses. This is the formula we have got through the pipes. So being based చేసుకొని we have done some problems. Next ఏంటి? We have to equivalent pipe. So what is the concept of equivalent pipe? by taking any problem you can say. So here we have the 3 pipes with different diameters and the common length, total length will be like this. So upon solving this problem, we are getting the derivation finally with this equivalent concept. We are getting the Dupit's equation, that is equals to L by d to the power of 5 is equals to L1 by d1 to the power of 5, L2 by d2 to the power of 5 plus L3 by d3 to the power of 5. So this is the things we have got with this equivalent pipe concept. Based on this, we have derived some problems. So in this session, you have learned 2 new topics, that is flow of fluid through pipes in series and flow of fluid through pipes in equivalent pipe system. So in the next class, we will discuss about the flow of fluids in pipes in parallel connection. What happens when the flow of pipe is flowing in a parallel connection? So okay, so with this I will stop the class. Hope you understood the topics of 2 things, that is the equivalent pipe and the series pipe connection and the problems also. So if you have any doubts, you can refer to the video, or you can just call me, or I will send the PPT for you. Okay, so keep practice the problems whenever you find time. Once the class is completed, I'll upload this video in the YouTube, and later the YouTube link is forwarded to your WhatsApp group. So the students, those who are not coming regularly to the class, just forward this link to your friends' WhatsApp personally, so that they can see what's happening in the class. So we are in the unit 3. About 70% of the concepts have been completed. Okay, only 30% is left behind. So we will complete these topics soon, depends upon the time factor. Okay, thanks for listening to the class patiently. We'll have the next class in the next session. Thanks for your patience being in this class. Okay, so I'll stop here. So tomorrow in the next class, we'll discuss about flow through parallel pipes. Okay, so 2 formulas. Based upon the 2 formulas, we have practiced 3 or 4 problems in this session. Okay, hope you understood the concept. So thanks for listening to the class. Have a nice day. God bless.